Hello everyone, welcome back to the channel that is 10-minute engineering solutions. In today's video, I'll show you how to control a motor using a 4 to 20 milliampere analog signal with a Schneider ATV320 VFD. This is brand of Schneider, the model ATV320 VFD. So we'll go through complete wiring, parameter setting and configurations and testing all by the step by step. So you are the first in my channel, so please subscribe first and then stay with me for from start to finish full video. Then you will be learn a lot of things from this video. It's the most important topic for you and the engineer and technician. Okay, let's start the video first. Okay, I will show you now the part 1, configuring parameters. So you can see the picture in here. So I'll go to the setting, so configurations, and now you can see the picture in here, step by step, and the full, and then sin, sin, and then enter, and going to the setting of the motor parameter settings, so BFR, standard motor frequency. You can see the picture in here. This is the frequency is 50. This is standard frequency of 50. Now NPR, you can see the picture in here. This is the rated motor power. You can see the VFD is 5.5 kilowatt in my system. So actually I'm using my motor side is 1.1 kilowatt. So I have to reduce the sizing of this VFD. So 1.1. You can see the picture in here. I'm just say it now 1.1 and then enter. Okay, now UNS, rated motor voltage. UNS means rated motor voltage. You can see the picture in here. So the motor nameplate have the value is 400. So I just mentioned in here 400 volts. So if you in your system have the voltages variations, you can adjust by scrolling this dial. So no problem. So in my system I have the 400. So I'm just set the 400 volts, and then NCR. You can see the next. NCR, rated motor current. You can see the picture here. So this as per design, the VFD was the 5.5 kilowatt, so that's why the current was 11.5. So my motor sizing is 1.1 kilowatt, so that's why I'm just lowest setting current. I'm just setting the 3.5. This is the 1.1 kilowatt setting as per design. So this is the 3.5 kilowatt. This is NSP. You can see the next setting. FRS, you can see the motor frequency, rated motor frequency as per the nameplate of the motor. And the NSP, the rated motor speed. I found in my motor have the speed is 1500, 1500. So that's why I'm just saying the value 1500, the rated motor speed. Okay, and then I have to say the ITAs, the motor thermal current. So this is the ITAs, motor thermal current. So I have to say the motor thermal protection current. This is for 2.8. This is the standard 2.8. So I just set all the value. So this is the motor parameter settings I have done completely. The configuration parameter is done from the part 1. Now I'm going to, you can see the right side of the done. Now the VFD basic parameter settings. I'll go to the configurations again and the full, and then I'll go to the scene and go to the acceleration time, ACC. I'll go to the ACC. Yeah, this is the ACC, acceleration time setting. So that default value is the 3.0 second, but I have to set this value and the 5.0. Yes, this is the 5.0. This is the acceleration time, and this is the deacceleration time. This is the deacceleration time for how much time later the motor will be off. It should be the 5. It will be very slowly they stop the motor. Okay, and There is the LSP, low speed motor minimum frequency. This is the motor minimum frequency. In your motor system, if you want to run the at least uh, 20 hertz, you can set the 20 hertz at off speed, off time. So, but I have to run my system is the zero system from the zero. When the motor is VFD is zero, the low LSP is zero means start from zero. HSP, you can see the picture in here. HSP means the high speed of the motor, high frequency, high speed frequency. I just set in my for my field device of 30 hertz. So this is the HSP. I just set my value is the 30 hertz. Okay. Now the full basic basic VFD parameter setting and group 2 part 2 is done. Like you can see the right side, and now I'm just going to the analog 42 mm parameter settings, that is part 3 for the analog configurations. Okay, you can see the picture in here. So now again I'm just going to configuration full and then going to this going to the I0 input output. This is the input and output setting, and then I'm going to the AI3. AI3 means analog, yes. AI3 next, yes, this is the AI3 and enter. This is the analog input setting. I've already after sometime later I'll describe you I3 AI3. I just mentioned the wiring connection, also the given the connection 42 milliampere connection. So this is the AI3 analog, you can see AI3 analog, and then scroll CRL3. CRL3 means the minimum current setting. So we need to set the 42 milliampere. So that's why the CRL3 is the L3 means minimum current settings, CRL3. So I have set to default setting is 0. So I need to set the 4 to 20 milliampere. So I have to, this is the minimum value will be the 4 milliamps. So I'll increasing the data. Here is be the 4.0. This is the 4.0. Yeah, this is the analog input CRL3, and the next CRH3 means the maximum current setting. Maximum current setting is 20. So this is default set value. So I no need to change the value because my setting also the 420 milliamperes. So that's why this one is also the 20. No problem. Don't need to change this value. Okay. Both parameters are done successfully. 20 milliampere and 4 milliampere. Okay, in your system have the 0 to 20 milliampere, no problem. You can change the minimum value 4 to 0 and then maximum is 20. This is your history. Please stay with me a full video until finish, otherwise you cannot understand clearly. So that's why full all the connections analog and comes into completed. Now I'm just going to the part 4. This is the wiring configurations and wiring connections. So that's why I'm just going to the start connection. First of all, I'm going to the connection to DI1 to the switching signal for plus 24. I'm just mentioning here for plus 24 to DI1 is just given the short jumper here. But if you, when you use in your system, you just using in your system have the switching system. For example, one system you want to run, when you want to run, you just make a switching that 24 to DI1. But I'm just, as per making a video, that's why I'm just giving the short jumper for make ready the VFD ready signal. This is the jumper. I'm just using jumper. In your system you can use for switching system. This will be the switching, otherwise them cannot work the properly, the 4020 milliampere also. So in your system you must use the switching for DI1 and 24 volt. So now I'm applying the connection of the, there is 4020 milliampere, that means common for negative sign connection 4020 milliamperes. This is the common connections. This is the common connections, and I have given now the AI3 connections. Now please stay with me until finish the video. Yes, this is common and AI3. That means 420 milliampere connection is done. Yes, this is the both two connections in here, common and AI3. 420 milliampere connection is done. You can see the picture in here. This is fully clear and specific. Wiring connection completed and done. Okay. Now I'm going to give in the analog signal. You can see the picture in here. This is the signal generator. Signal generator means we can generate the 420 milliampere from this device, 0 to 10 volt, and 0 to 20 milliampere also. We can measure also the 420 milliampere, 0 to 10 volt also. So that's why I have no field device in here. So that's why this is the common connections and this is the positive connection. So that's why I'm using the signal generator for giving the VFD 4 to 20 milliampere signal for test purpose. Okay, I'm giving the connections. A positive sign in, you can see the picture in here. Positive sign in connected from the yellow cable from the signal generator output. And you can see the input connection of the VFD and output connection of the VFD. Motor connection also given before start the video. Also they given the motor connection also before start the video. Okay, I'll show you how I run the motor very smoothly and carefully with the using the analog signal. Okay, now I'm giving the signal from the signal generator. You can see there is 00. VFD is ready now. So I am applying now from the signal generator. This is the signal generator. So now this is the 00 milliamps. Again show you the connections. You need to connection the very carefully. And now I'll show you after applying the 420 milliampere what happened in the VFD and the motor. Okay, please stay with me until finish the video. You need to check the before giving the signal 420 milliampere signal. You have to check the verification of the connection 420 milliampere common and AI3 connections and 24 volt and DI1 switching signal. Okay, now I given the signal. You can see the 4 milliamps equal to the VFD's set value is 0 because I'm setting the CRL3 is, you know, when I increase the milliampere, the VFD is increased, the hertz and motor also run. You can see the picture here. So I'm increase the 4 milliampere to the 5 milliampere. Now VFD is 2.5 hertz. If I again increase the 6 milliampere, you can see VFD is increased and motor also speed is increased. Yes, motor also this speed is increased. This is the analog signal functioning very smoothly working and happening. You can 7. If I change the value is 7 milliampere, you can see I'm giving the 7 milliampere. VFD speed is increased. Also motor speed is increased. That means the full system is working very well. You can see here motor is running very well conditions. Now milliampere is 7 and speed is 7.5. If I again increase the milliampere, 8 milliampere, VFD speed is increased and motor also speed increased. You can see the before and now. You can see now when I reduce the frequency and milliampere, then motor speed is also the reduce. You can see the picture in here. You can see now the 2.4 is equal to 0. Motor speed is also the 0. So I hope the video is fine very well. Thank you for listening to me here today and thank you. Please subscribe my channel.